Welcome, everyone, and thanks for listening to my PlatformCon talk, Infrastructure as Code from Templates to APIs, a platform engineering story. My name is Juan, and I lead the cloud native technology team at Banking Circle. Banking Circle is in the business of payments, that is, moving money between currencies and across borders. And to do that, we have different teams working on the technical side of things. We have teams that are doing APIs. We have teams that are working on the core banking systems, teams that are doing anti-money laundering, and teams that are integrating with the clearinghouses of different central banks. As platform engineers, we have to support all of these other engineers in Banking Circle that are, in all cases, building in the public cloud. We use Azure, but are using different programming languages, different architectures, and different ways of working. Back when I joined Banking Circle, and this is in 2021, the way in which we were provisioning infrastructure was entirely manual. We had instructions like the ones you can see in the picture here, and then there was a person in charge of that who was able to follow these instructions and create the resources that everybody needed. Of course, this does not scale very well. And because of that, one of the first things that I did when I was in Banking Circle was working into putting everything we had for infrastructure into an infrastructure as code definition. I was working first in a particular team, the team building the client-facing API, but soon I realized that I could expand that approach to other teams. To do that, I came up with a building blocks approach. These building blocks were pipeline templates for Azure DevOps and Terraform modules. The idea was that any engineer, any person working in engineering could then use these building blocks, the templates and the modules, and with that get the infrastructure that they needed without having to wait for anyone to follow any instructions for them. The pipeline templates look something like this. You had to provide some details, and then you got your resources. And the Terraform modules looked something like this. So we would have modules for the elements that people would need most of the time, such as storage accounts, key vaults, web apps, databases, and some others. Now, once that we had expanded this approach across all the company, we had different teams that were working with infrastructure as code that could provision infrastructure on their own without having to wait for anybody else. We thought, well, these building blocks is working. People have the modules, the templates, they just have to put them together. Therefore, we can adopt this mentality that you build it, you run it. As a developer, you can now take care of this, so you can and you should take care of it. The problem is that all of these putting building blocks together, especially when they are about infrastructure, is most of the times not in the comfort area and not in the core domain of expertise of the developers that are using it. So we would end up with situations like this, where they try to build something, following some examples, some documentation, but the moment that they need something a bit more specific, we end up with a bit of a disaster. And then we wanted to look at why that was happening. As platform engineers, we knew that we were providing the building blocks, but when people were putting them together, there was a bit of friction. So we tried to understand what was going on. And the process looked a bit like this. When someone needed some infrastructure to run their code on, the process was something like they would first have to create a resource group, then to create groups in Entra ID, grant some RBAC assignments to those, then create a service principal to deploy into that resource group. After that, they would have to take these Terraform modules, put them together to build the Terraform project, and they would also have to take the pipeline templates and then put them together to have a Terraform pipeline that could run the plan and apply steps. Then, of course, they would have to run the pipeline, and assuming everything works, then they are done. But if something doesn't work, which of course is what happens a lot of the time, they then had to go backwards in the process and redo some of these steps. So this was not a very nice way of working, because it is complex, it is cumbersome, and it is out of the core domain area that the developers are working on. So it puts a lot of cognitive load on them. This leads to day one operations being hard. When you have to set up the process from scratch, oftentimes you don't really know how to put all of that together. But sometimes you can copy something and then you're set. But day two operations get harder because if you don't look at this very often, then maybe you want to make some additions some months into the future and you didn't really grasp how that putting building blocks together worked. Which leads to the platform engineers having to be there supporting the developers and spending a lot of time in this support. So it's a situation that is not nice for anyone involved in the process, not for the developers, not for the platform engineers. Furthermore, from these same building blocks, because they are just pieces, they can be assembled in different ways. So teams were building different solutions, even if they were based on the same building blocks. And that makes it harder to support that. So again, as platform engineers, you would be oftentimes calling to support something regarding infrastructure. And then you would first have to understand how those building blocks were put together. So at this point, and once that we had analyzed the situation, we thought, well, we have to do something. Let's try to make this better. And we started looking at all of those resources that were repeated again and again, for which we already had these Terraform modules. We realized that most teams needed the same resources, the same package, which would include that resource group and then access on it, which would include some elements for security, some elements for observability, and then some resources that are used for configuration and for storing state. So we thought, okay, let's give them that package and let's give them that following best platform engineering practices. Evan Vocher has this definition of platform engineering that I really like, that is now over 7 years old, which essentially tells us that a platform should be a self-service product that allows these teams to then, in an independent way, deliver at a higher pace. So we started thinking, okay, we want to give them this package. We want to do that as a self-service product so that they can deliver at a higher pace. How should the interface look like? And we came up with these three elements that are simple to understand and to remember. We wanted to make that interface simple, single, and self-service. That is something that is simple to understand, that is intuitive, that anyone can quickly get used to. Then having a single interface as opposed to putting building blocks together, just providing one single configuration file with everything you need. And of course, exposing that in a self-service way. And when we were thinking about how to define that interface, of course, we thought in using the YAML language that people are already familiar from other elements, such as, for example, those pipeline templates. And we came up with something like this. This is an actual example from our internal platform, where teams would tell us, well, this is the prefix that I want to use in all of the resources. This is the Azure DevOps project, where I have my code, where I have potentially some pipelines that are going to deploy on top of this later. These are the members that therefore need access to the resources. And then these are the resources that I need. In this example here, we're seeing a valid one, but a very simple one, where we have one resource group in North Europe and a storage account inside it. From that simple YAML file, we are creating something like this. So we are granting the person handling that YAML file the resource groups that they request with the resources inside the resource group. And of course, this does not support any resource that exists in Azure. It is an opinionated offering. So through that, they can get the resources that we see teams needing again and again. We are including elements for, again, security and observability into the package. And we are integrating all of that with Microsoft Entra ID for access and with Azure DevOps in case they have to deploy anything afterwards. So from that simple YAML file, we are creating all of this. And we are not only doing that the first time they provide the YAML file, but rather that YAML file lives in a shared repository. Any changes to that YAML file lead to changes in the resources. So anyone can manage the resources just by working on that simple file. Whenever there is a commit, that is merged into the main branch. And of course, we have some validations in the pull request to ensure that that is going to work fine. Then the changes are immediate. So the developers get a much nicer experience. But actually, under the hood, this is still using Terraform and Azure pipelines. What we have done here is just having a pipeline that is triggered automatically every time that any commit is merged, that then runs a Terraform project that is reading these YAML files. And this is working quite well because it makes it so much easier and more intuitive for the developers to handle these resources. But we think we can also take it farther. And that's why we're also looking now into taking these interfaces and making them APIs. And to do that, we are using the magic trio. We are using three open source projects that you can see here, which are Argo CD, Crossplane, and OpenTOF. Essentially, what we want to do is Argo reads those YAML files from the repository. Crossplane is then interpreting those YAML files and extracting that into the actual resources that have to be created. And then with the OpenTOF provider, we are taking care of the provisioning of those resources. The YAML files look essentially like the same that we have seen before, but now we are adding some more fields at the top. So now we have metadata, and we are also defining a particular API version and a particular kind of resource in that one. Because through Crossplane, we are creating actual Kubernetes resources, which means that, of course, people can still provision these things through the repository in the same way that they are doing when we have the solution with Terraform and pipelines. But they can also maybe work locally with the Crossplane composition installed, and they can then try how would it look to deploy one of these resources from their local machine. This then presents some advantages. For example, we're using OpenAPI schemas to define the Crossplane custom resource definitions. So this allows us to have proper versioning for the APIs and proper schemas, which is something that we can put in place in the other solution with the pipelines and the Terraform code. But in this case, it's just built in, so it's much easier to manage. We also make it very discoverable because by being an actual Kubernetes resource, people can do stuff like kubectl explain that particular field. And because we're using Crossplane too, we are continuously reconciling this. What we're using Argo CD and Crossplane, each of those has an independent reconciliation loop. So this leads to a situation where like the desired configuration in the YAML file and the actual configuration in the resources is checked all the time and not just when changes are introduced. Therefore, we reduce quite a lot the possibility of those resources drifting. That's what we are looking at now, and that is our platform engineering story. Thank you very much for listening. If you're interested to know more, if you have any questions, please connect with me on LinkedIn. You have a QR code on this slide to do just that. And if you're interested in Banking Circle and you want to see what we do and which positions we have open, please check our website, bankingcircle.com. Thank you very much and enjoy the rest of your platform.